Oh, switch to default. Okay.
Go, there's this sound. I can see that it appears to actually be listening to me now. At least something in the room is listening to me. 2 minutes to go. I'll just leave the stream on then. So we'll get going in a minute. Have like a clock that counts down. You got less than a minute to submit. Push the button. Get credit. How many people submitted the design project? How many people? Was it someone in here who submitted the 404 syllabus? That was what they submitted for their design, was the 404 syllabus. I thought it was very ambitious, actually. I want to do on my own database. I'm like, cool, that's really awesome. But I don't think that's quite the idea. The other amusing one is somebody put the word hi. You'll see these, because they're all going to be public. Somebody put the word hi on a piece of paper, and then like took a picture or scanned it or something. I don't know, maybe they made a PDF that way. That was very, very original. So there's a few people who are like pushing the edges of what I said, and that's fine. I don't have a problem with it. It's amusing, if nothing else. And then there were quite a few people who actually like tried to do something. So that was good too. If you found this a challenging exercise, writing a design going, I don't really know what I'm doing, perfect. That's actually where I expect you to be. But now you at least have some idea of what you don't know. So as we start talking about what you need to know in order to build a good design, the next time you do this, you'll have a little more insight. And by the time you get around to writing your actual design for your capstone project, you'll be writing a design you care about. And it will hopefully help you inform your implementation so that you are, ideally, you are delighted by how much progress you make when you have a good design. So I'm going to get started. Assuming I got the date right, it is September 26th. The boring logistics slides, which I just put there because otherwise people will ask those questions. Like somebody said that this wasn't on some particular website. I'm like, yeah, but it's in every single slide, every single lecture. So it's easy to find and refer to. All right, so don't forget that there is a post-lecture self-assessment activity on Thursday. Have you noticed that I changed them around a little bit? So, it'll randomize the questions, the kind of introspective question. I tried to limit that to 1 or 2 or 3, depending on how I felt that day, rather than asking you like 8. Are the review questions about the material useful? No one found them useful. Oh, good, and then I can stop doing them. Great. Thank you very much. Oh, 1 person found them. So I have to do it because now 2 people. Okay. Okay. Fair enough. So I could do better. Maybe I should ask you to suggest a question. That would be a nice exercise too. Crowdsourcing questions. I did that last year for the final, and I had some very interesting questions on the final exam that people had submitted. And everything had been done on Piazza, so everybody could see them all, and yet people still got them wrong. That was great. Next week, the review for Design Project 1 is due. That's why Canvas has that weird date that says October 3rd. The peer review on Design Project 1 is due next day at 5. I know, 5 o'clock is kind of a weird time, but I was like, that way you have nothing else to do but listen to me natter on for 90 minutes because there's nothing else you have to do for this class in general. Let's see, there's, the usual self-assessment things. Nothing else has really changed there, blah, blah, blah. Oh, I didn't do it here today. So this, blank. I failed. Today's failure is I failed to put a failure in there. Oops. Design Project 1 was very interesting to watch the conversation and discussion. It made me realize some things about the DS Labs that I hadn't fully appreciated when everybody was focused on building an implementation. Not the least of which is, there's no design for DS Labs. What it is, it's a collection of tests where they said, hey, here's some random shit you have to pass. And they don't really give you insight into why. For example, I mean, I knew this is one of the gotchas. There's an edge case where you have a view that has a primary in it, but no secondary, no backup. And the view server picks a backup and proposes it to the primary. The primary has to say, everything's ready, you can actually change to the new view. The reason for that, anybody remember why or know why? Or hopefully you talked about it in your design. If not, that would be one of the important things to do next time. What's the failure condition there? So why wouldn't I just simply immediately want to make the backup available to switch over to be the primary? Right! It's a replicated database. Hey! Backup server, you have an empty database. Now primary goes away and you say, okay, I'm going to replace the database with stuff in it that I've told clients about with an empty database. All your bank records are gone. You're okay with that, right? All that money you put away, all 64 cents, it's lost. Oh, come on, you're all starving students, right? You know, so it's like, anybody have a dog or a cat? They are always hungry. They're always starving, no matter how fat they are and how much food they refuse to eat. The moment you open up something delicious, they're there. Students, same thing, money. So again, that's why I found it very interesting. And I said, they don't really actually have a clear design. And so one of the challenges here is to extract a clear design from this. I think that maybe next time, if I ever do this again, I probably won't quite just point people to the DS Labs, because it's not unheard of for people to have very crappy understanding of the problem they're trying to solve. In fact, I would say that most of the times in the real world, when you work for real companies and they come to you and they say, hey, we want you to build this really cool widget, you're going to say, okay, well, what does it have to do? And they'll come up with some random hand-wavy things. Well, it needs to never crash. It needs to never fail. It needs to be 100% efficient. Okay. You think maybe you're being just slightly unrealistic here? It's got to be consistent, highly available, and partition resistant all the time. And you're going to start. You know, the fat guy sat up front and told me I can't have all three. I can have two. Maybe I can get some of the third one, but I'll probably have to give up some of one of the others in order to achieve that. Design is one of those things where it's really hard to conceptualize what it's supposed to be until you see a crappy one. And then you get an inkling of, wow, wouldn't this have been better if only it had talked about this case where the primary hasn't got the backup up to date yet. This is one of those failure conditions where you say, I can't solve this in an automated way. The solution for that particular case is call a human to solve it, or an AI agent with enough brain power, right? Probably better than the human, but not quite yet. Yo, ChatGPT, what would you do in this situation? Grab your backup tapes. So the purpose behind the peer feedback, which is now what the next activity is, you get to see what other people did. You're going to see a small sample. You get 3 of them to review. If you didn't submit your own, you won't be assigned any to review. We can manually assign them to you, so you won't completely lose out on all those points. Is there anyone in here who submitted a design project? Even if it was just the 404 syllabus, which I think is kind of funny because, of course, 404 is, access denied. So a couple people did submit. Good. Did anybody in here submit a course syllabus for some course other than 416? Someone did. I know who it is, but it doesn't matter. I was humorous. When you get down and you try to implement this thing, you're probably going to be unhappy with the design. You're going to say, this doesn't really fit very well with this artificial straitjacket you've given me called DS Labs. Because people were already trying to squirm their way into, how am I going to tell people what to implement here? And it's like, I don't want you to tell them what to implement. I want you to tell them the problem you're trying to solve and the general approach that you want them to take. If you want to go all the way down to giving them pseudocode, and someone did ask about that, I'm like, is that what you'd want to get? Because maybe it is. If the person you're giving your design to is not, they're a really good coder, and you will meet people like this in your career if you haven't already met some people like this, people who you put in the corner and you have them churn out code, and they're really good at that. But maybe they're not really good at solving problems. They need a structure in which to do that. Maybe you're one of those people. There's nothing wrong with that. There is plenty of room for people like that. But in distributed systems, what you have to be able to do is identify the problem, propose a solution, and think about how am I going to make sure my solution works in all of these edge cases. You know, when this is GUI programming, somebody complains because they don't like the color of that button. And so you change it or you make it customizable. So, oh, you don't like teal, you can have aquamarine instead. In distributed systems, you don't get to have that kind of interactive feedback loop. What happens is you promise somebody that you're going to give them a key value store that isn't going to lose their data. And when they call you up, it's because I can't get my data. And I guarantee you 100%, because I've been in that seat before, when a customer is calling your employer saying, I can't get my data, and it's your project, you're going to know. And if you're really lucky, you will be one of those people they actually send on site. You've never had the joy of being on site until you show up at some customer's site where they're having horrible problems. It can only be seen at their site. And you get there, and the first thing they do is they greet you warmly. They're very glad that you're there to solve their problem, and they ask you that question. And it's always the same question. How long is it going to take you to fix this? How long is it going to take you to fix your broken code? It will take longer than you think it's going to, right? Yeah, that's not a fun question. And then they get unhappy with you, but whatever. So DS Labs doesn't provide you with a model. It uses test cases that Ellis Michaels inherited from MIT that basically say, here are the things we are going to be looking for. And that's okay, but that's not even a good set of requirements. You could extract some requirements from that. Sometimes you might need to look at a system and say, what does this system do because I have to reverse engineer it? But I'm not teaching a reverse engineering course. I'm teaching you a distributed systems course. So in the end, I think what you're really doing is trying to write the design document that should have been included there. It said, here's the problem you're solving in this particular lab. Here are the issues that you need to consider, and here is an approach that you might want to use because it will pass the test. That's fine. That's a perfectly reasonable approach. What were the components? We had clients, we had identical database servers. That is not necessarily that the database contents were the same, but the actual servers, the code, were the same. So the point is that when we started out with a pool of servers and we picked one to be a primary and one to be a backup, they have the same code on them. That code has to be able to work when the primary gets kicked out and the backup becomes a primary. And there was a nice conversation about, well, what happens if the primary then comes back? Could you use it? I'm like, you might be able to use it. Since it has a lot of state, it would be a lot cheaper to bring it up to date. But that's a recovery problem now, isn't it? And the simplest recovery model there is, nope, sorry, you went away, we replaced you. You know, it's like working for a company. So you get sick, you go out on leave, you come back, and there's somebody else sitting in your chair. And they go, we don't need you anymore. We put all your stuff in a box and we lost it. And then we have this view server thing. This is the configuration database. But it's a configuration database that plays a little bit in the system. Has just a small role, but it's an important role. It identifies what the current configuration of the system is. one of the questions that came up, and it's a really good question because I worked through both sides of this. One of the questions that came up is, can a client call the primary or the backup, or is it only allowed to call just the primary? Honestly, they didn't ask, but you could also ask, or maybe it only calls and asks the backup. It actually doesn't matter. You can make it work with any of those models. And that's why this is a design problem and not an implementation problem. What are the benefits of having multiple servers? Now, if you want to go to the full read-write replication, I can tell you from personal experience, it's hard to get that to work right. That's what we're going to be talking about on Thursday when we start talking about consensus. Getting two computers to agree on anything is hard. If you walk through this design, you begin to realize, wow, this is way harder than I thought it was going to be. There's all sorts of edge conditions that are going to leave me with an inconsistent database. And I'm just a key value store. It's the simplest of databases. Well, except we're going to throw append in there to really screw with you. I can tell you, I had this conversation. So normal interface for a key value store is get, put, and delete. Can you think of any other protocol that uses get, put, and delete? HTTP! It also has post. Post is kind of like append. We're going to put that in there just to really screw with your head. Post becomes a structured data submission mechanism. So I can send you some structured information, not just a blob of stuff. Question? It has to be replicated properly. So the append has to be done in the same order on both of your servers. See, if you update variable X and I update variable Y, or key X and I update key Y, the order in which those happen is not coupled. The reason append becomes complicated is now we are both modifying the same key. We potentially are doing it on two different servers, and we have to do those in the same order, or we don't have a consistent database. I can never ask for the contents of a key from the primary and the backup at one instant in time and get a different answer. Now, the moment there's an instant in time difference, all bets are off because you can race. This happens in multi-threaded programs. I don't know, anybody ever written a multi-threaded program? Anybody knows what a thread is, I hope? That's a 313 kind of thing, right? Right, so one of the things that happens in multi-threaded programs is that two different threads can access the same piece of memory. And let's say one of them is reading it and the other one is writing it. And so the one that's writing it is constantly changing the values. You actually don't know what value the reader is going to get out of that. Now, what's more interesting is when you get both of them reading and writing the values. So, you write the value and then you read it back. It may not be the value you wrote because the other thread may have overwritten it. It's exactly the same problem here, but now we have to serialize this. Well, when we did this with threads, we used locks. We'll spend more time coordinating our locks than we want. Part of the problem we are trying to solve is how do we do this efficiently? How do we implement an atomic test and set or an atomic update in a way that will work across our replicas? So design project 1, which is just this primary backup server, is not a particularly hard case, but the moment I put that append in there, now I have an ordering constraint. I've created a causal relationship between those two threads. And they're separate replicas. It's not the same piece of memory. We are building replicated memory. Yeah. Append is a read, modify, write cycle. So if I perform, let's say you send an append command and it shows, and you send an append command. Your append command goes to the backup first, your append goes to the primary first, and then vice versa. Now your strings are different. Literally, you're appending in the wrong order. You have to maintain the ordering. Remember when I was talking about how there are operations that can be isomorphic even if they're done in different orders? Then there are operations that cannot be isomorphic if they are done in a different order. So the things we care about in getting our system consistent here is making sure that those places where they are causally related always are done in the exact same order on each of the nodes. And we're going to see this come up over and over again. When we go and start talking about consensus on Thursday, which chapter 14 should be terrifying because it's a huge chapter. And what I'm probably going to do is go through it fairly quickly, and then we're going to come back to those issues and delve into them more deeply later. But I want you to begin to see what happens when we try to generalize from project 3 in DS Labs, the primary backup server, which is just 2 servers, to making it 3 or 4 or 5. Because that's the interesting problem. That's the problem people pay you the big bucks to solve. And that's what half the class wants. The other half the class just wants world peace. That's the half that's not here. So what is a client? A client is some independent execution state that can query the view server for the current view, the current active view. There could be internal state changes while we're trying to jigger around and add this backup or promote it back up to the primary. That should not be visible to the client. The client should send a request and say, yo, get me that key value. Now, get is a really interesting case because we were talking about could you send it to the primary or could you send it to the backup? Well, if they are actually properly serialized, you can send it to either one and you'll get the same key value. Or you'll get a range of key values that it could have gotten, depending on the order in which the get arrived. We don't have to make clients that are racing against each other work correctly, any more than we have to fix threads that are racing on the same data element. If they want to serialize, they can do it at their level. I've had that conversation way too many times. You don't have to fix broken software. If people are racing on a value in memory or they're racing on keys in your key value store, not your problem. It's their problem. So, our clients are very restricted. They will not proceed to a new request until the current request is answered. All they can do is send that request again. This makes handling that in the server pretty easy because it says, well, if I can't handle it right now, I just drop it on the floor. The client will send it again. This is known as at least once. That's what a client implements. At least once semantic. The server is enabling the complement of this, which is at most once semantics. That means the server keeps track of at least the last commanded answer from each of those. What happens? Okay, so I get a request ID, last one I remembered. Well, that means I received my answer, so I request it. It's clearly already done, because I can reason about the fact that send me another request until it reaches one. That's part of it. Request is the same as I just send the same response back, because the response wants me. I will only execute that command at most. If I never get it, I won't execute it. If I get it, if you send it to me again. That section of exact, very nice semantic for us to have client in our server. Implementations of the same logic. Programs. Turing machines are state machines. Do buy a Turing machine. How's that? Anybody? Yes, in the 30s. That's all right. The British in the 50s. The same input string input as our schedule of events, because this is a method stream our event. In that interface, entirely between the servers, happen put and delete our data. It's a problem that you needed to solve of this particular project. And when it's not very interesting, it's come, I haven't made it here. How do I guarantee the messages? And what? Yeah, I think of this as being a series of steps, one after the other, but the reality, and as I walked through on Discord, there are essentially 3 components in our simple system, right? We have eyes here means partition server. So as long as so you could make that part on availability, so we'll service our clients because we own the database. The view server will provide them with our services. So the reason you might want to include making your services, it doesn't really. You got a question? Only if the client, when there's a view change, an external, when the view, right, change that has been acknowledged, then the client can ask the view, how does the client learn that it has changed? Well, view number, and if I'm a server and I get there to the client, one message across the network to do something, let's send 2, including, and that's why I was going through the